Okay, so this is section 5.5, the separation of a mixture of soluble solids. I wanted to take some time to go through this with you guys because I know the reading part of it's a little bit confusing. The first thing that I want you guys to think about as we talk about this particular section is the lab that we did in chapter 4. Let's see if I can go find it real quick. The one that was the effect of temperature on solubility. This one right here, 4.4, the effect of temperature on solubility. If you recall, you had two test tubes labeled A and B, and then we put some, we added water, and at room temperature, neither one of them really dissolved very well. And then we took the two test tubes and we put them in a beaker of water on the hot plate and we heated them up. And as we heated them up, test tube B completely dissolved to where there was none left. And then test tube A didn't really appear to dissolve much more at all when we heated it. So test tube B, that substance became much more soluble when you heated it. And then we took them and we returned them to room temperature, and what we found with test tube B is that all that solid material that had dissolved now precipitated back out of the solution and formed what looks like these little crystals. But all of it came back out of the solution once we cooled it down again. That's what we did in chapter 4, lab 4. So the way that this relates to section 5.5, first of all, we're using the exact same substances. Potassium nitrate is our substance B from chapter 4, and sodium chloride was our substance A. And they're using the same idea that solubility is affected by temperature, and we can use that characteristic property to separate some solids that are both soluble. So basically what we do, we start off with, and there's not a picture of this here, but we start off with potassium nitrate and sodium chloride in a test tube mixed together, no water. Okay, so originally it's a mixture of two solid materials, sodium chloride and potassium nitrate. Both of them are like salt. They both look like salt, like white, kind of like crystally powdery. So when they're mixed together, it's hard to tell if it's two different substances or one substance and exactly what it is. Now, in order to separate that mixture, again, it's a mixture of potassium nitrate and sodium chloride with no water. We want to separate them into their individual parts. So we put the mixture into some water. And what happens at room temperature is that a little bit of the sodium chloride will dissolve and a little bit of the potassium nitrate. But we're going to put so much into the water that most of the sodium chloride and potassium nitrate don't dissolve at all at room temperature. Okay, again, there's not a picture of that here. We're just thinking through the process. So at room temperature, we're not going to have very much dissolve at all. Now, because neither one has really dissolved, we still can't separate them just yet. So what we do is we heat up our solution. Now, when we look at the temperature that says 70 degrees Celsius, that's pretty hot. We're talking like, close to 100 Fahrenheit, maybe 120 Fahrenheit. So it's pretty warm at this temperature. So we heat up the whole solution to 70 degrees. And what we're going to find is that all of the potassium nitrate will dissolve into the solution. So right here where it says at 70 degrees, in solution is all of the potassium nitrate. All of it's dissolved. You can't see it because it's dissolved into the blue water. Now we also know that at 70 degrees, a little tiny bit of the sodium chloride is going to dissolve, because we do know that salt will dissolve in water, just not a lot of it. Salt's not it's not highly soluble, I should say. So yes, it'll dissolve, but just not that much. So there's a teeny little bit of sodium chloride in the solution, but most of the sodium chloride is here, found as a solid undissolved. So what this is reminding me of is 5.4. Yesterday, when we had the mixture of salt and sulfur, we had just enough salt so that it would totally dissolve, but the sulfur stayed kind of floating in the solution. So this is the solid left over, the stuff that's floating. So now what we can do is we can use the separation by filtration that we saw in lab 5.4 from yesterday. So we take this solution, remember it's still heated, so all the potassium nitrate's dissolved, and we're going to filter it. So this is part A, and now we're on to part B where we filter it. And remember, we're going to keep it warm here. When we filter it, all of the sodium chloride, which is the yellow stuff, will get stuck in the filter paper. and the liquid solution will go through the filter paper. And remember, we call this the filtrate. What you need to recognize is that in this solution is our dissolved potassium nitrate. So now we have our sodium chloride separate from our potassium nitrate, because the potassium nitrate is still dissolved in the water. So if you look here, it says solid on the filter paper is most of the sodium chloride. In the solution is all of the potassium nitrate and still a little tiny bit of the sodium chloride. So we haven't completely separated it yet, but we've separated most of it, where we have most of the sodium chloride here. Now, in order to get the potassium nitrate back again out of the solution, because it responds very easily to temperature, we're going to take it and cool it down. So here at this temperature, it's 70 degrees. Now we're going to take it down here and cool it down. So standing at room temperature. So we've now, it's like taking our test tube B from lab 4.4 and putting it back in regular water. We're going to see all of that stuff precipitate out of the solution. So this green stuff at the bottom is our potassium nitrate. So at room temperature, the potassium nitrate will precipitate back out of the solution. So here it says solid is most of our potassium nitrate. Now, what you have to remember is that at room temperature, some potassium nitrate dissolves and some of the sodium chloride dissolves, but most of the potassium nitrate will precipitate. Now, to separate the sodium chloride, the potassium nitrate from the solution, we're going to filter it a second time. So when we pour this through the filter, the potassium nitrate, which is represented by the green stuff, is going to stay in the filter paper, and the liquid solution filtrate is going to filter through. So if you look and see here, the first time we filtered it, we separated the sodium chloride. The second time we filtered it, we separated the potassium nitrate. So we've essentially separated a mixture of sodium chloride and potassium nitrate by adding it to water and heating it up and then filtering it and then cooling it down and filtering it a second time. If we wanted to then take this remaining solution, which has a little potassium nitrate and a little sodium chloride, we probably could evaporate a bunch of the water and then to where some of it will precipitate out again. So if we get rid of some of the water, some of that stuff's going to come out of solution. And we could continue to then filter and then change the temperature and evaporate the water in multiple steps until we were able to separate this little tiny bit of remaining potassium nitrate and sodium chloride. But what you really need to know, forget about that last part there, the main thing that you need to know is that this process is called fractional crystallization. The crystallization part of the word comes from the fact that when the potassium nitrate cools down again, it precipitates out of the solution and it forms these crystals. So we are doing fractional crystallization. Again, the word fractional means part of the whole. And remember, the whole thing at the beginning was potassium nitrate and sodium chloride mixed together. And so fractional means we're going to separate them into fractions by crystallizing one of them. So that's where the word fractional crystallization comes from. And that's how that process works. If you have any questions, please let me know.